Hi everyone, in this video we will understand to find inverse of a matrix of order 2 by 2 and 3 by 3. Some questions to try at the last of this video lecture. Hi everyone, in this video we'll discuss about the inverse of matrix. How to find inverse of a matrix. Before finding the inverse of a matrix, I want to tell you one thing, that in this video we'll discuss a small trick which will make you able find inverse of a matrix. Means this trick is very useful for you. Invertible matrix. Now if A is a square matrix, means a matrix should be square matrix, then only we will be able to find the inverse. In A is a square matrix of order n, then there exists another matrix of B of the same order such that AB equal to BA equal to I, identity matrix. Then we say that B equal to A inverse. A we have given, and if we can find another matrix B in such a way, if we multiply both the matrix A and B, then if we are getting identity matrix, it means B is inverse of A. Now to find the inverse, we must be aware about some elementary operations. These elementary operations are very important. Now, what are these elementary operations? Elementary row operation and elementary column operation. We can apply these rules which I am going to discuss now, can be applied in row wise and column wise both. Now first of all, it must be a square matrix as I have told you before. Now we can do interchanging of two rows. This is allowed. Means I can interchange R1 with R2. I can replace their position. Now second is multiplying all elements of a row by a non-zero scalar number. It should not be 0. Any other number we can multiply. Any other scalar we can multiply. Suppose we have R1 and I can multiply with M with all the element of R1. So I can write it M R1. Similarly, in column also I can do the same thing. In column I can write C1, I can write LC1 in that way. Adding the element of a row or column, the corresponding element of any other row multiply by a scalar. This is a little tricky one, but the combination of you can say second one. How can we find it? Suppose we have R1 row, and in R1 I can do this R1 plus 2 R2. Means I am multiplying corresponding element of R2 with 2 and I am adding it with R1. Let's take an example. Suppose I have a matrix 2 3 1 2. Suppose this is the matrix I have. I can do this if I will apply this rule. See what will happen. R1, this is R1, and if I'll apply this, then what I will get? In place of 2 I will write 2 plus 2R2. 2 into R2. R2 means this is R1 and this is R2. R2 means first element is 1. So after simplifying this, 4 I will write here 4. Similarly, In place of 3 I will write 3 plus 2 into 2. 2 to the 4 plus 3, 7. So here I will write 7. So this way we will get another row, another R1, and R2 will remain same. This is the elementary row operation, very important. And similarly, I can do subtraction. If I will write here minus 2R2, then it will be minus here. Similarly, I will get the corresponding answers. Similarly, I can apply the same rule, second and first, on this matrix. Now we'll see that how to apply these rules. I have written these rules in short here. You can see 3 rules were there. Same rules we can apply in the columns also. Elementary transformation, elementary row transformation we will see. To apply these rules, we must know these rules first of all. We can write A equal to IA, that we know by the property of matrices, and in place of A we will write the given matrix A, and identity matrix we will write. It depends upon which order they have given us. If A is of order 2, then we will write I2. If it is of order 3, if this is of order 2, we will write here order 2 identity matrix. If it is of order 3, then we will write here 3 order identity matrix. Now by using elementary row operation, we'll try to convert it into I, and this will remain as it is, and correspondingly this will be convert into another matrix, say that B. If I am getting BA equal to I, then B will be inverse of A by the definition of inverse of a matrix, as we have studied. We will do the process to find the inverse of a matrix. Now the trick says we have to start with this A11 to make it identity matrix, then this will be 1, then we'll change this into 0, and then this one, and then we'll change this one, and we are trying to convert it into identity matrix, so this will be 0, this will be 1, and this will be 0. So this is the trick. This one, this, and change this one. This is for 2 by 2 matrix. If it is of order 3, then we'll start with this element 1 0 0, then this one will convert A22 into 1, obviously, to make it identity matrix, and then this one 0 and 1 again, 0 and 0, and finally this one as 0. By elementary row operation, you have to follow this for 3 by 3 matrix. If you follow this rule, then it will be very simple for you to solve. Like obviously this will be 1 1 and 1, you have to convert these into ones, and rest 6 zeros, and this one 1 and 1, and this is 0 and 0. This is a trick which is to be applied. Let's try some question. inverse of a matrix by row transformation, elementary row transformation. In this question you will see we have element 1 3 2 7. Now we are lucky here that first element is already 1, so you must be remember that I told you about the trick 1 0 1 and 0. So first is already there. Now our target will be to make this 0. Before that we will write it in this way. Equal to and A. Here we will write 1 3 2 7, the given matrix, and here we will write identity matrix 1 0 0 1. So the first term is already there 1, so need not to change. Now this 2 will try to make it 0. How can we do this? By elementary row operation we can say this is R2, this is R1. If I'll do R2 minus 2R1, now whatever operation I am doing here I have to repeat it here. But in R1 I am not doing anything, so I'll write it like as it is 1 3, and this will be 1 0. Just write it as it is. Now why I'm doing it? Because I want to make this 2 0. Then what I have to do, 2 minus 1 into 2. If I'll do like this, it will be 0. And 7 minus, I can show you the calculation here, 2 minus 2 into 1, it is 0. And 7 minus 3 into 2 means 1. This we have got 1. The same way we have to do here also. 0 minus 2 into 1, it means minus 2. 1 minus 2 into 0 will not affect, it will give you 1 only. Now our next target is to make this 1, it is already 1, so need not to change this. Now we have to convert this 3 into 0. This 3 will be our target now. To convert this into 0, what we have to do? We will multiply and subtract. We will multiply this R2 by 3 and will subtract it. So in R1 we will do R1 minus 3R2. When we are applying some property, so in that case we will only concentrate on that particular elements. Like here what we can say, according to this rule, R1, what is the element here? 3 minus 3, and corresponding element at R2 is 1, so it will give you 0. It was our target. Now in place of 0 in place of 1 it will be R1 is 1, so 1 minus 3 into 0 will give you 1 again. So in that way we have got the matrix like this: 1 0 0 1. So we have got the identity matrix, but our work has not been finished yet. We have to apply the same property in this R1 also. In R2 we are not doing anything, so just write as it is, minus 2 and 1. Now applying rule, what we will get here, 1 minus 3 into minus 2 will give us 7. So just write here 7, and similarly it will be minus 3. Now this is I, this is a matrix, let's say it is B. If I'll multiply with a matrix, then if I'm getting I, it means that is a inverse. So B is inverse of A. So this is A inverse, we can say 7 minus 3 minus 2 and 1. And this way we can get the required answer. Now we'll try to find inverse of a matrix of order 3 by 3. I have taken one example. Now see the solution. First of all, we will write A equal to IA. This implies that 0, 1, 2, 1, 2, 3, 3, 1, 1 is equal to, we'll write here identity matrix. Now our target is to convert this into identity matrix of order 3. So what we will do first, we will interchange R1 with R2. Then 1, 2, 3 will come in place of R1. And in place of R3, no changes. Same changes we will do in this identity matrix also. 0, 1, 0, 1, 0, 0 and 0, 0, 1. It will remain, R3 will remain as it is. Which property we are using, we have to write here. R1 interchange with R2. Similarly, now our next target is to make it 0. It is already 0 according to the rule or trick I told you. Now this 3 is to convert into 1. How can we do this? How can we convert it into 0? If we multiply as a number, if we see, if I multiply 3 minus 3 into 1, if I'll do this procedure, then I'll be getting 0 in place of this. And this shows this is this 3 is an element of R3 and 3 and 1 is an element of R1. So in such way I have got the idea like which procedure I must apply here. By applying this procedure, this will be in first and second row no changes, so we will write as it is. And in third row, this will be 3 minus 3 into 1, it means 0. 1 minus 3 into 2 means minus 5. And similarly this is minus 8, 1 minus 9. And same procedure we will apply here in place of in identity element which we have converted. Now it does not remain identity element. 0 minus 3 into this, it is again 0. 0 minus 3 into 1, so it is minus 3. 1 minus 3 into 0, it will remain 1 only. And rest all the element we will write as. Now our next target is to make it 1, and it is already 1. Now we'll think about this minus 5. To make this minus 5 0, what we have to do, we'll multiply this 1 with 5 and we'll add it. It means we can do R3 plus 5R2. So it will give us 0 in place of minus 5. How it will be? Minus 5 plus 5 into 1, it is 0. Now we will apply this rule here. It will be 1. Now in R3 we have to do the changes only. This is 0 already. 0 into 5 into 0 will again give you 0. Minus 5 plus 5 into 1 will give you 0. Minus 8 plus 5 into 2 will give you 8. 5 to the 10. This is 2. And similar procedure you will do in place of this R3. 0, minus 3 and 1. And here you just have to write whatever will happen if I'll do this procedure. It means 0 into 0 plus 5 into 1. It means this is 5 minus 3 plus 5 into 0. This is minus 3 only. If 0 is there, and this will remain same, it means. And rest all the element you will write as it is. Now our next target will be to convert this into 1. We are following this rule. Now this will be 2. This 2 will become 1 if I'll divide this by 2. It means if I'll write here R3 1 by 2 R3. This is also a valid rule which we have discussed. It means this will become 0, 0 and 1, and same way this will become 5 by 2 minus 3 by 2 and 1 by 2. Rest all will write as it is. Now our next target is to make this 2 as 0. If I'll multiply here with 2 and if I subtract it with this, then it will be 0. It means R2 minus 2R3, then it will make it 0. See what will happen here. If I'll multiply here with 2, if I subtract it, it will become 0. And 1 minus 2 into 0, these two zeros are there, so it won't affect this row. Means in R2 we are applying, so we'll write only R2, and rest all first and third row we will write as it is. Same here, we'll proceed with the same procedure. Now you can see that I have written all the elements here. 1 0 0 is the R2's element, and minus 2 multiply 5 by 2 minus 3 by 2 and 1 by 2 are the element of R3. If you simplify this, you'll get the new R2, new second row. It will be minus 4, and here it will be 3 and minus 1. This minus 3 and minus 3 will make it plus. This is negative and this is negative. Rest all the elements will remain same. Now our next target is to make this 0, 3. How can you make this 3 0? If I will follow this rule, R1 minus 3R3, 3 minus 3 into 1 will make it 0. because these two are already zeros, so these 1 and 2 will not be affected. So these element will be 1 2 0 0 1 0 0 0 1, and we will apply the same rule here in this R1 also. For that R1 we will write all the element 0 1 and 0, minus 3 minus 3 minus 3, and R3's element, that is 5 by 2 minus 3 by 2 and 1 by 2. If you simplify this in R1, you will be getting 5 minus 15 by 2. This will be 9 by 2. This will be minus 3 by 2. And rest 2 rows element will remain same. Now our last target is to make this 2 as 0. To make it 0, if I multiply this 1 with 2 and if I subtract it with 2, I'll be getting 0. 2 minus 2 into 1, it means 0. It means I have to apply this rule on R1. R1 minus 2R2. Now in R1 I will be writing these two are zeros, so this won't affect the other elements. This will become 0, this will become 0, and now only changes will be there. And R1 elements are minus 15 by 2, 9 by 2, minus 3 by 2, and 2 into minus 2 into minus 2 into. R2's element is minus 4, 3 and minus 1. We just have to simplify and put these values in place of R1. After calculating, we'll find this value, and in R2 and R3 all the elements remain same. Now we can say this as identity matrix, and this is, we'll say as B A, and it means B is inverse of A. So A inverse we have got, that is this matrix. This is the required matrix inverse of A. Thank you everyone. Please like, share and subscribe. And subscription is required, because if any updates will be there, you will be getting the updates very soon. And like also, and share for this with the students who require these facilities. Thank you very much. These are some questions of exercise 3.4 to practice. Thank you.